Section 9.5 goes over the limitations of the significance test. Some of these are a little hard to understand, so you may need to read this a couple times, look at any associated problems the authors provided, etc. So, statistical significance doesn't mean practical significance. When we conduct a significance test, we're trying to figure out whether the true parameter value is above or below the value in the null hypothesis. Remember, we assumed that was true. We didn't say it was true. And the second thing is whether the true parameter value is sufficiently different from the value in the null hypothesis to be of practical importance. So those can be two different things. So what the significance test does is give us information about whether the parameter differs from the null hypothesis value and its direction from that value. By direction, we mean is it bigger or smaller than that. Statistical significance, again, is not the same as practical significance. You can get a small p-value, probability value, such as 0.001, and that's statistically really important, significant, but it doesn't necessarily imply anything in a practical sense. When the sample size is large, you can get a small p-value like that. When the point estimate is the number we have in our sample, like x bar or p hat. When it's near the value in the null hypothesis. So when that happens, you're going to get this kind of number regardless. So it's useful, but it can be overused. So it says whether the particular parameter value in h sub naught, the null hypothesis, is plausible. So if we go back to the example of Bill and his siblings washing dishes, we say, is that null hypothesis that he was not washing dishes random, purely random? Is it plausible or not? But that's all it says, plausible. It doesn't really say anything more. So if we say it's not plausible, it doesn't really tell us which ones are plausible. It just says we're going to reject that one. So when you do a confidence interval, it actually gives you more information because it displays the entire set of believable values. And if you get a small interval, you've kind of narrowed it down to ones that will actually be useful for you. So sometimes they're misinterpreted. Remember, we've been saying this all week. Do not reject the null hypothesis. It's not the same as accept the null hypothesis. We never do that. So when it isn't smaller than the cutoff value of alpha, and most of the time that's 0.05, it doesn't mean that the null hypothesis is correct. It just says, well, we don't know. Just like when Bill had a 40% chance of not washing dishes in 3 nights by chance. Well, that was plausible, but we didn't accept that it was chance. We just said we can't really say otherwise. So the true parameter value we don't know. And we find the small p-value doesn't really tell us whether it differs how much from the assumed value in the null hypothesis. It may be right on the button. It may be quite different from it. So it's a fine point, but the p-value isn't the probability that the null hypothesis is true. It's the probability, and this is a long sentence phrase it's got here. The p-value is the probability that the test statistic that we created from the sample takes an observed value or beyond in the tail, given that the null hypothesis is true. But we don't really know if that null hypothesis was true, recall that. So it's not the same as the null hypothesis is true given the observed test value. And that's the part that's probably extremely hard to understand for most folks. So what if you get something and the results were not statistically significant? You still should report it. And some of the tests you get that are significant will be that way just by chance. If you had a different sample, it may turn out that they're not statistically significant. And the true effects may not be as large as initial estimates reported by the media. The media always reports things that are more interesting. When you get maybe where it didn't work out, they don't report that. That's not considered news. The old saying, dog bites man is not news. Man bites a dog, that's news. And that ends our section.